Hi, in this video we'll have a look at the types of list we have in Java. In Java we have a list interface. In this video we'll have a look at 5 classes which implement this interface. The first class we have here is vector. So vector implements a growable array of objects. Like an array, it contains components that can be accessed using an index. And vector is synchronized. So all the methods you observe in vector are synchronized. Here we have our vector with 3 elements 2, 3, 1, and we are printing it and we get the result as 2, 3, 1. Next we have a stack implementation of a list. Stack class represents a last in first out stack of objects. It extends vector and has push, pop, peek, empty as some of the new methods. So here we have our stack class, takes 2, 3, 1, prints a stack, and you can use its method like stack.peek to check what is at the top of the stack. So currently we have 1 which went last and it's first out, so 1 is at the top of the stack. Next, the most commonly used list implementation is an array list. Underlying, it uses an array, and every time the array gets filled up, it increases the size by 50%. So if you have an array list with an underlying array of size 10 and it gets filled up, it will increase the size to 10 plus 5, that is 15. Create a new array and copy your objects from the old array to the new one. If you know the index number of an object in the array, you can reach it very fast. But removing an object is a costly operation, as it has to be removed from the underlying array and other elements need to be shifted to occupy this newly empty place. So here we have our array list and we have our usual elements inside the array list, and we are printing our array list here. Next, we have a linked list implementation of lists. Slow read write operations, as you have to reach that place one by one using usual linked list pointers. But removing elements are cheaper because you don't have to shift elements like an array list. Just the pointers are needed to be rearranged. So here we have our linked list. We are putting 2, 3, 1 in it and printing them out. The last implementation we'll look is copy on array list. So this implementation has been created for multi-threading scenarios where you have a lot of read operations and a lot less write or modification operations. Copy on write array list, as the name suggests, for every write, the original array list is kept intact. A new array list is created with the modification. So if you have a lot of writes, this is not a recommended implementation to use. At last, let's see one of the things which is very interesting about an array list. If you remember the basics of an array, it's a contiguous space allocated in memory. So if you give a very large initial memory to an array list, you can throw an out of memory exception. Still getting allocated, and now it has thrown an out of memory exception. So if you have a very large number of elements to be stored in a collection, array list might not be the best choice, or you will have to somehow divide the large number of arrays into manageable chunks before allotting arrays to it. Thanks for watching.